In the last class, we started with this topic tension. Okay, I told you about what is the tension in the string. So I hope you remember about the tension. Tension, what I told you about tension is a type of pulling force. It's a type of pulling force. Now, what exactly happens in tension is that two bodies. Let me change the color. You can see here two bodies, MA and MB, are attached to each other with the help of a string. Okay, they are attached to each other with the help of a string. This string, and body B and body C are also attached to each other with the help of a string. And there is an external force F applied on the block C. Now, if I say that all the three blocks are moving together towards the direction of the applied force with an acceleration A, then which force is responsible for the motion of block B and block A? Which force is responsible? It is tension in the strings. Only the tension in the strings are responsible for the motion of block B and block C towards the direction of the external applied force, because no other force is there. You can see they are not in direct physical contact, so there is no contact force. They are connected via string, so the only force which is present in between them is tension. So tension is responsible for their motion. Okay, now there were some assumptions I told you about the string. What are the assumptions? Here are written as well, that the mass of the string should be negligible. Mass of the string should be negligible. String का कोई mass नहीं होना चाहिए. ठीक है. Second of all, string is inextensible and inelastic. This is the most important assumption, that the string is inextensible. If the string is not inextensible, then it will not be able to keep the bodies together. ठीक है ना? Inextensible का मतलब क्या है? कि स्ट्रिंग के दोनों एंड्स की लेंथ चेंज नहीं कर सकते आप खींच करके. अगर आप वो कर सकते होंगे तो फिर क्या क्यों जो है वो फोर्स ट्रांसफर होगी बाय स्ट्रिंग. इफ द स्ट्रिंग इज एक्सटेंसिबल, देन द फोर्स, एक्सटर्नल फोर्स F, will not get transferred via these strings to these blocks. Okay, if the string is elastable or extensible, the string will get extended due to the as a result of the applied force, and it will not transfer that force to these blocks, and hence these blocks, block B and block A, will not move together with block C. I hope the concept is clear about what the string does. Okay, and I guess I can see here I also gave you a numerical in the last class to solve. I don't know pretty much how much you remember about this, but we can solve another numerical. हम एक और कर सकते हैं. There's no big deal about this. Okay, we can make another numerical, and if you are comfortable, let me just give a numerical to you. Let's suppose again there are two blocks. Is my yellow ink? There are two blocks, block A and block B. Block A and block B connected via this string, and if I say a force F is acting on both these blocks, and the angle which this force makes, just Deepika, am I not audible to you? If you can rejoin, Deepika. Deepika, just rejoin the class. And why is nobody else joining? This is so frustrating. I don't know why people do these things. I've given a notification always and every time, at least 1 hour before. I'm giving you a reminder that you have a class at 5:30, and still you join so late, and some of you just don't join. That's irritating. Okay, so these are two blocks A and B, and let me give you mass as well. This that will be more clear. So block B is of, let's suppose, say 3 kg, and block A, let's suppose, is say of 2 kg, and they are connected with a string, and the external force F is applied at an angle 60 degree from the horizontal. This angle is 60 degree from the horizontal X. Okay, and if I say that the external force F is equals to 10 Newton, then you have to calculate the tension in the string. Okay, so your question is to calculate the tension in the string. Calculate the tension in the string. आई होप द क्वेश्चन इज प्रीटी मच क्लियर. क्या करना है आपको? दो ब्लॉक्स हैं, एक 3 kg का, एक 2 kg का. इनको हमने स्ट्रिंग से कनेक्ट किया है. ओके, सो both these blocks are connected with the help of a string, and they have their respective mass, and they are applied by an external force F. This is F external, which is equal to 10 Newton. ठीक है, एक्सटर्नल फोर्स लग रही है और किस एंगल पे लग रही है? 60 डिग्री विद द हॉरिजॉन्टल. सो एक्सटर्नल फोर्स इज अप्लाइड एट एन एंगल ऑफ 60 डिग्री, 60 डिग्री विद द हॉरिजॉन्टल. So try to calculate the tension. I'll give you 1 minute time. Just try to calculate the tension meanwhile. Good, Deepika, good. Just try to solve the question. जो मैंने अभी दिया, आपको repeat भी कर दिया. Try to solve the question. You have 1 minute time. I've given you a force, and I've given you at what angle it is inclined with the horizontal, and I've given you the mass of the system. You just have to calculate the tension in the string. And I'll give you a hint, not hint, information. Basically, you can take OFO, I guess. Yeah. Hint is you can take G is equals to 10 meter per second square. The value of G you can take 10 for your easier calculations. So now try to solve it. What hint I was talking about, I'll give you hint also. If you're not able to solve without hint, take hint. Hint is that resolve this external force. Okay, resolve the external force into components. Resolve external force into components. Now this is a hint, a very major hint. If you do this, you will be able to solve it. You have to resolve this external force F into component forces, and then you will find the way how to calculate tension. Okay, so hint is there, time is there, question is there, everything is there. Just solve the question quickly. Everyone here, two of you are there. Are you able to solve it? Let me see. No answers, guys. No answers. You want me to solve T 50 Newton? Okay, I have one answer. T is 50 Newton. What about Deepika? Okay, not a problem. दीपिका इधर देखो, आप हम साथ में सॉल्व करते हैं. You just listen to what I'm telling you how to solve this. So I guess you didn't pay much attention to the hint which I gave you. Hint पे ध्यान नहीं दिया ना किसी ने भी? That you have to resolve this. Okay. If you resolve this F external force, so the horizontal component of this will be Fx, which is equal to what? F cos theta. F cos 60 degree, and you will have a vertical component of this external force, which will be F sine 60 degree. Okay, now just tell me, what do you guys think will be the direction of motion of these two blocks, whether it will be horizontal or it will be vertical? Okay, this is pretty much clear from the diagram itself that both of these blocks will move in horizontal direction. That means that the forces in vertical direction are already balanced. Okay, and that is why there is no motion produced in the vertical direction. Vertical direction में already forces सारे balanced हैं, इसीलिए these blocks will not fly away because the forces in vertical direction are balanced. These blocks will move in horizontal direction. Why? Because there are unbalanced forces present only in the horizontal direction and not in the vertical direction. This thing is pretty much clear. Now, if at all it is that much clear, still how do you solve this question? The question is that. First of all, tell me what will be the F cos 60 component. This is 10 Newton. Cos 60 is 1 by 2. So Fx will be 5 Newton. So your force in horizontal direction is 5 Newton. Okay. And F sine 60 will be 5 root 3. Okay, because sine 60 is root 3 by 2. You know that. Okay. So that's how you have resolved this. And the net acceleration is in the horizontal direction ax. So first you have to calculate your net acceleration. How will you calculate your net acceleration? If you consider both A and B block as a system altogether, if you consider them as a system altogether, so you can write this as a single block of 5 kg. You can add the masses. Consider both the blocks as a system. Okay, consider both of them as a system. So you have to add their masses. Consider them as a system. You can simply write a block of 5 kg is being acted upon by a horizontal force of 5 Newton. So what will be the acceleration of the block now? The acceleration will be total force 5 Newton upon mass 5 kg. So your acceleration will be nothing but 1 meter per second square. This is your net acceleration in horizontal direction ax. Okay, net acceleration in horizontal direction. ये आपने एक्सेलरेशन निकाल लिया आपने पूरे सिस्टम का. आपने पहले मैंने बताया आपको सिस्टम क्यों माना. आपने सिस्टम इसलिए माना बिकॉज बोथ ऑफ देम आर मूविंग टुगेदर. ये दोनों ब्लॉक साथ में मूव करेंगे इसलिए आप इनको सिस्टम मान सकते हो. सिस्टम मानोगे तो आप क्या करोगे? यू विल एड देयर masses and you can simply redraw this diagram as a single block of 5 kg is being acted upon by a 5 Newton force in horizontal direction. Now you have the force, you have the acceleration. It's very simple to calculate the tension. Now how will you calculate the tension? Simply if both these 2 kg block and 3 kg block are moving together, then tension is the force which is pulling this 2 kg block in horizontal direction, it is tension only. So if I draw the FBD for 2 kg, I can write tension force in the forward direction, and there is mg downwards, there is n upwards. But since the vertical forces are balanced, I need not to go in the vertical forces. I just need to worry about the horizontal force. If I say tension is the only force on the 2 kg object which is responsible for its motion, so I can write tension is equals to net mass into the net acceleration, because tension is the only force which is responsible for the motion of the 2 kg block. Okay, because you see no other force in horizontal direction, and since the motion of the 2 kg block is in horizontal direction, the force responsible for its motion will be tension, because there is no other force. ठीक है ना? क्यों मैं टेंशन बोल रहा हूँ कि रिस्पॉन्सिबल है, क्योंकि वर्टिकल में और कोई फोर्स आपको दिख रही है 2 kg ब्लॉक पे एक्ट करती हुई, और सॉरी हॉरिजॉन्टल में कोई और फोर्स दिख रही है 2 kg ब्लॉक पे एक्ट करती हुई? जो फोर्सेस हैं टेंशन के अलावा वो दोनों वर्टिकल में है। एक तो है 2 kg ब्लॉक का वेट जो डाउनवर्ड लग रहा होगा, अर्थ खींच रही है अपनी तरफ, एंड क्या है आपका नॉर्मल रिएक्शन जो कि आपकी कॉन्टैक्ट फोर्स है। सरफेस जो सरफेस पे रखे हुए हैं उससे परपेंडिकुलर लग रहा है कॉन्टैक्ट फोर्स, नॉर्मल रिएक्शन, and both of them are balanced. That is why there is no acceleration in the vertical direction. Sir, can you don't mind 5n by what are you trying to say, Prasanna?
Hello?
Yes, Prasanna.
Sir, once repeat that, sir. 5n by 5 kg. I didn't understand what you told.
5n by 5 kg you didn't understand. Okay, tell me, do you know how to resolve the external force into component forces? This F external, which is equal to 10 Newton, I resolved this into horizontal force Fx and a vertical force Fy. Okay, how did I resolve this? Because angle which was given to me was 60 degree with the horizontal, and I've told you several times that if the angle with the horizontal is given to you, then the component on the horizontal is your cos component of that vector. Okay, so for the force, it will be the cos component of the force on the horizontal side, because the angle was given from horizontal. ठीक है, तो horizontal component, so horizontal component is 5 Newton. Simply I put the value of cos 60. Cos 60 value is what, 1 by 2, and F is equal to 10 Newton is already given to you. So 10 into 1 by 2 is your 5 Newton. That is your horizontal force. Now I told you that both 2 kg and 3 kg are moving together in horizontal direction. Okay. If they're moving together, that means both of them have the same acceleration. Okay. If they are moving together, this means both of them have same acceleration. And if I'm saying that both of them are moving in horizontal direction, that means they have a net force in horizontal direction, and all the forces along the vertical are balanced. What are the forces along the vertical? If you have attended my FBD class, you would have known this, that the forces are nothing but your normal reaction and your weight experienced by the body. These are the forces in vertical direction, and both of these forces balance each other. That is why there is no net force in the vertical direction or along the vertical direction, and hence there is no acceleration in the vertical direction. So now I know 3-4 things. What are these things? That both the blocks are moving together and they are moving in horizontal direction, and the net force along the horizontal direction is 5 Newton. So I considered both the 2 kg block and 3 kg block as a system. Why as a system? Because they are moving together. So I added their masses, and I simply replaced this system of 3 kg and 2 kg separate blocks by a single block of 5 kg, and I applied a force of 5 Newton as it was applied on the 3 kg block when they were not together, because nothing has changed. If I do this, nothing has changed, because when they were separated, these 3 kg and 2 kg blocks were separated, then also they were moving together, and due to the action of the same 5 Newton force, that is why nothing has changed, and I can replace this by a single system. If I replace them by a single system, I can calculate their acceleration. How do you calculate the acceleration? Net force, which is 5 Newton, divided by the net mass. Okay, this is your net force of the system, 5 Newton. This is the net mass of the system, 5 kg. Okay, so net force divided by net mass gives you net acceleration, which is 1 meter per second square. Now, you can use this acceleration to calculate the tension. Tension was present in the string, and tension force was responsible to pull this 2 kg block towards the horizontal or along the x-axis. And only force which is present along the x-axis for this 2 kg block, or the only force in the horizontal direction for this 2 kg block, is your tension. Okay, just keep listening to me. I'm not giving you any break. I'm not stopping anywhere, because this I'm going in a continuous flow, because that is important. That is how you will understand how the things are connected in this question. Okay, it is a multiple concept question, but just follow the flow. And I've repeated 2-3 times. I hope now 5 Newton by 5 kg is clear to you. Final step is, I told you that this tension is the only force which is responsible for the motion or the acceleration experienced by the 2 kg block. So you will equate this tension by the net force on the 2 kg block in horizontal direction. So that is what you did. You simply write net force on horizontal direction is equals, which is tension, nothing but tension. So this is, you are calculating net force in horizontal direction on the 2 kg block. And you already know by the FBD that the net force in horizontal direction is tension only and nothing else. So tension is equals to 2 into 1. That is your, again, your mass, which is 2 multiplied by your acceleration, which is 1. So your tension will be 2 Newton and not 50 Newton. Prasanna, now tell me, is the numerical clear to you? It's a very interesting numerical, by the way. Tell me, Prasanna. Dear, are you clear? You are not clear. No. Okay, again tell me, where is the issue? Prasanna, what is the issue to you, Prasanna? Okay, now you say it is clear. Okay, Deepika, have you understood? Deepika, समझ में आ गया बेटा? Who was raising hand? Okay, no problem. Moving on. I was about to teach you bigger concept today. Don't just stay entangled in this concept. इसमें उलझ के मत रहो. आगे पढ़ेंगे आज. और आप बहुत कम बच्चों ने ज्वाइन किया है. Was hoping कि अच्छे सब लोग आएंगे. So that I could take the class forward. What can I say? Okay. If this is clear to you, I would like to shift to the next concept, which is related to this only. We'll study about the pulley system. We'll study about the pulley system. Before touching pulley system, let me give you another very important thing, and this I will use encoder for this. What if you are given a system of blocks which are not connected with the help of string? Let's say this is a block M1 This is another block M2, and this is another block M3. Okay, what if the condition is somewhat like this: M1, M2, and M3, and there is an external force applied, F external, on this block M, but they are not connected with the help of any string. So now, will they move together? Okay, if they move together in what is the force which is responsible for their movement? These kind of question may arise in your mind. So first of all, let me tell you, yes, they will move together if despite the absence of the string between them. उनके बीच में अगर कोई string होगी या नहीं होगी, इससे कोई फर्क नहीं पड़ता. ब्लॉक साथ में चलेंगे. इस केस में भी, इस केस में क्या होगा, इस केस में क्यों साथ चलेंगे, क्योंकि धक्का देंगे एक दूसरे को. ठीक है, दे all the blocks, okay, since they are in physical contact with each other, they will push each other along the same direction. And what is that direction? Direction of the external applied force. Whatever is the direction of the external force, the blocks will push each other along that same direction. Okay, so which force is responsible for the motion? In this case, it is contact force. Contact force among the or between the blocks. Contact force between blocks is responsible. Okay, they will have a certain acceleration, common acceleration. They will also, all the three blocks will have a common acceleration. How will you calculate that common acceleration? I'll give you a direct shortcut to calculate that. Okay, you need not to go in some equations and solving, although you can solve using equations, but I'll give you a very direct, which is a direct formula for calculating the common acceleration of all the three blocks is net force, F external, net force upon net mass, m1 plus m2 plus m3. Okay, so we want to calculate the net acceleration. The formula is net force on the system. You can combine all the three masses and you can consider all of them as a single system. Okay, so net force on system divided by what? Net mass. That net is not the correct word. In if I talk about mass, it should be total mass of system. Okay, that's how it should be. So this is a very good example as well. You can get a question in this form as well if the blocks are not connected with the help of a string, and then also one of the block is acted upon by an external force. So in that case, how will you calculate the net acceleration? And similarly, if I say m1, m2, m3, these three blocks are acted upon by an external force, but this time I tell you to calculate the contact force between m1 and m2. Or let's suppose I tell you to calculate contact force between m2 and m3. How will you do that? There's for that also you have a shortcut formula. So first I'll give you the formula and then I'll give you a question, and you can solve using this formula. You can solve those questions. I don't know if you're following me. Are you following me? Both. Okay, somebody else has joined. Malini has joined. And okay, no use of joining this late. By the way, Deepika and Prasanna, are you following me? Yes. Okay. Very good. Very good. Okay, this is a older. Yes. Just give me a hand raise. Okay. Request Deepika and Prasanna if you are not able to follow. Encode. Yeah. So what is the shortcut to calculate the contact force? I'll teach you also, not just give you the formula. You have to, if you want to calculate the contact force, let's say you have to let's say you want to calculate the contact force between first let's take m1 and m2. So let's take this example. You want to calculate contact force between M1 and M2. What you will do in this case is simply remember that the contact force present between M1 and M2 is responsible for pushing both M2 and M3. Just a minute. Yeah, sorry for the. Okay. So if you want to calculate the contact force between M1 block and M2 block, you have to remember that the contact force between M1 and M2 is responsible for pushing both M2 and M3. Contact force which is present between M1 and M2 is responsible for pushing both these blocks M2 and M3 along the external force. So the contact force will be equal to M2 plus M3 multiplied by your acceleration of the system, A net. Okay, that's a very simple shortcut. What is to be remembered? That you have to leave the mass on which the external force is being applied. Just per external force lag rahi ho, you have to leave that mass. So in this case, the external force is getting applied on M1, so we will leave the M1 in the formula. So there is no M1, there is only M2 and M3. Okay, and the A net. What will be the A net of the system? Acceleration, net acceleration of the system will be external force, net external force F upon total mass, which is M1 plus M2 plus M3. This is your total mass, and this is your net external force, which is the which was a shortcut for net acceleration. So I hope you now know the shortcut, and now you will remember also for calculating the contact force between these two blocks. So it will contain the block on which the external force is not acting. Okay, you have to include only those blocks on which the external force is not acting. Okay, and since the external force was acting on M1 block, so I have left M1 in the formula. Similarly, on the similar lines, if you want to calculate the, let's say, this was M1, this was M2, and this was M3, and this was the direction of the external force. If you want to now calculate the external force between M2 and M3, between M2 and M3, okay. So contact force present between M2 and M3, जो M2 और M3 के बीच की contact force है, it is responsible for pushing M3 only. Okay, the contact force between M2 and M3 is only responsible for pushing M3 along the direction of applied force. So that will contact force will be M3 multiplied by net acceleration, E net. So M3 into F upon M1 plus M2 plus M3. Okay. Did you get this shortcut quickly? Yes or no? I'll give you a question then. Did you get this? Everybody. Okay. Deepika and Prasanna say yes, yes. I'll give you a question. Okay. I'll give you a question. Malini also says yes. Okay. Very good. Again, I'll take three blocks. Let's say First block is of 3 kg. The second block is of 2 kg. The third block is of 1 kg. And they are applied by an external force which is equal to your 12 Newton. Okay, so 3 blocks are there, 3 kg, 2 kg and 1 kg. They have been applied an external force of 10 Newton on the 3 kg block. So you have an external force of 12 Newton acting on the 3 kg block, and the 2 kg block and the 1 kg block remain attached to, all of them are attached to one another. Okay. So you have to calculate what? Okay, calculate everything. Calculate the acceleration of the system, A net. Okay, net acceleration of system. So first you have to calculate the acceleration of the system. This is the first thing. Second thing which you have to calculate is the contact force between 3 kg and 2 kg. First you have to calculate contact force between 3 kg and 2 kg, and then you have to calculate contact force between 2 kg and 1 kg block. Okay, first you have to calculate contact force between them, and then you have to calculate contact force between them. So yeah, do it. First is acceleration, second is contact force between 3 and 2, and the third is your contact force between 2 and 3. So start. This is a 30 seconds question, not even 1 minute question. 30 seconds question. If you have rightly understood the formula and everything, this is merely a 30-second.
नहीं बैठो आज नहीं मम्मी
दीपिका, आप किस चीज का आंसर कर रहे हो बेटा? आपने बताया नहीं है. So you have to be specific. जैसे मल्ली ने लिखा है ना 1, 2 and 3. You have to be specific like that. Prasanna, what about your answers? Are you trying? This is a very simple question. Don't take this much time in this. Okay, we'll do this together. What will the net acceleration of the system? A net will be nothing but the total force 12 divided by the total mass 3 plus 2 plus 1. What is the total mass? 6 kg. So your answer is 2 meter per second square for the first part. Second part is contact force between 3 kg and 2 kg. Oh, contact force between 3 kg and 2 kg. Now contact force between 3 kg and 2 kg is responsible for pushing both the masses 2 kg and 1 kg. So I'll write C. Let's say the contact force between 2 kg and 1 kg is C1. So I'll write contact force 1 is equal to 2 plus 1, that is the 2 kg mass of 2 kg block and 1 kg block, multiplied by the net acceleration. So this is nothing but 6 Newton. Similarly, if I say C2 is the contact force between the 2 kg block and the 1 kg block. So that is responsible for pushing only 1 kg block. So that will be the mass of 1 kg block multiplied by the net acceleration, that is 3 Newton. So 2, 6 and 3 is the correct answer. Sorry, 2, what I have done. 2, 6 and 2 होगा ना ये 2 into 1. 2, 6, 2 is the correct answer. Prasanna is saying 2, 6 and 10. Prasanna, you were right for the first two, but your last one is not correct. I hope you have understood. 2, 4, 2. Nobody has given the right answer. 2, 4, 2, 2, 4, 2. Why are you guys calculating the second contact force as the 4 Newton? Prasanna was able to correct it, right? Second will be 6 Newton. Yeah, tell me. Where are you guys facing problem? Okay. You want to do another numerical on this? एक और करना है? But that will be pretty much simple. Like, there's a hand raise. Yes, Prasanna.
Hello.
Yes, Prasanna.
Sir, contact C2 is equal to 3 plus 2 into 12 by 6.
Which one? In which one? Third part.
Yes, sir.
Third part 12 by 6 is nothing but 2 only. And you have to calculate in contact force between 2 kg and 1 kg. Between 2 kg and 1 kg. So contact force between 2 kg and 1 kg is responsible only for pushing the 2 kg block. So you have to write the mass of only the 1 kg block and not 2 kg block. So the total mass here I have written as only 1. And then I have multiplied this with the net acceleration, which is 2 meter per second square. So this is not mass of the 2 kg block, this is acceleration. So 1 into 2, this is your acceleration, A net. This is this thing, A net. Okay, so that is why 1 into 2 is 2 Newton. Because what I told you here. In this case, the contact force between M2 and M3. M2 and M3 is responsible for only pushing M3. Okay, so the mass of M3 multiplied with your net acceleration. So M3 into F upon total mass. So this thing is your 2 meter per second square for the question given. And M3 is equal to 1 kg. So 1 into 2 is 2 Newton. That's why the answer is 2 Newton. Prasanna, clear? KK, sir, understood. Okay, good. But what if you have understood it wrong? What if this concept is wrong? That's not, this concept is not wrong. What if you guys have not understood? So I just want to check once again by giving another case. This is some different case. You can say this is case 2 of the similar type of connected. This topic is basically the motion of, you can say, connected bodies. So there are two bodies which are connected and they are moving together. So both of the bodies are moving together. So that's why we can say case 2 of motion of connected bodies. We are studying motion of connected bodies. So up till now, the external force was only from one side, but in this case, I will apply two external forces. Okay, this will be F1 external, and this will be F2 external. F2. So in this case, there are two different external forces acting from both the sides on the mass M1 and M2, which are in contact with each other. So how will you calculate the net acceleration in this case? So in this case, the net acceleration will be decided by the direction of motion of both the blocks. If M1 and M2, both of them are moving towards right side, okay, that is towards the direction of F1. Okay, so I can say net acceleration is F1 minus F2 upon total mass M1 plus M2. And similarly, if both of them were moving towards left side, that is the direction of F2. So the A net would have become F2 minus F1 upon total mass. So this thing, denominator remains constant. You have to change only the numerator depending upon on which side both of them are moving along what force. If they're moving towards right, they're moving along the direction of F1 force. If they're moving towards left, they're along the direction of F2 force. So you have to always subtract the smaller force from the bigger force. If they're moving along left, the greater force is F2 and the F1 is smaller, so greater minus smaller, F2 minus F1. That will be the case here. And zook, 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 zook. Let's just consider that they are moving towards the right side. This is your formula for net acceleration. E net. How will you calculate the contact force in this case between them? This is the bit tricky part. Hana, you want to calculate contact force in between them. So in this case, the contact force between M1 and M2. Okay, first calculate the contact force on block M1, and then we will calculate on the block M2. Did you get this? First, we'll calculate the contact force on M1. So in order to calculate contact force on M1, you have to write the mass of M1 multiplied by the external force which is not acting directly on M1. What is the force which is not acting directly on M1? It is the F2 force, which is not acting directly on M1, because F2 force is acting directly on M2 and not on M1. So so M1 into F2 upon the total mass, M1 plus M2. This will be the contact force on M1. Okay, and what will the contact force on M2? It will be the mass of N2 multiplied with the contact force which is not acting directly on M2. So M2 पे कौन सी force है जो directly act नहीं कर रही है? It is F1. F1 is the force which is not acting directly on M2. Okay, because F1 is acting directly on M1. So M2 into F1 upon net mass M1 plus M2, and then you will add both of them. So the formula will become what? Dum dara dum dara mast mast. Okay. Formula will become M1 F2 upon M1 plus M2 plus M2 F1 upon M1 plus M2. Now, if you want to take M1 plus M2 common from here, you can write it simply as M1 F2 plus M2 F1 upon M1 plus M2. Okay, so the formula for contact force between M1 and M2. This is the formula, and that is the logic. So I'll explain both the logic and how do you derive this formula. So for contact force, you have to keep in mind only one thing, that you have to take the mass of the object on which you want to study, on which you want to calculate the contact force, multiply it with the force which is not acting directly on it. Okay, multiply it with the force which is not acting directly on it. All the forces which are acting directly on an object will not result in the contribution of contact force. Okay, जो भी forces object को directly act करती है, उनकी वजह से object में contact force नहीं आएगा. So I hope you understood this small short trick, logic, whatever you want to call this. Okay, so based on this, can we do a small numerical? Yes, we can. We have time. Okay, I will extend this thing to a system of 3 kg blocks, and that will be really very interesting. What I'll do is, the question will be, there's a 3 kg block, then there's a 2 kg block, and then there's a 1 kg block, and there's a force acting on the 3 kg block. This F1 is equals to your 12 Newton. Okay, and this is an F2 force acting on the 1 kg block. This is equals to your 6 Newton. Now you have to calculate three things again. You have to calculate net acceleration of the system. Net acceleration of system, one thing. Second thing is contact force between 3 and 2, which is C1, and the contact force between 2 and 2 kg and 1 kg, which is C2. So calculate C1, then calculate contact force C2. Okay. Try this, everyone. Hope all of you are trying. Just try this. Okay, try this question. Are you guys able to solve this? I've included 3 masses, but the concept remains same. One answer is 1 Newton. Acceleration is 1 Newton. That is correct. What about, why are you guys taking this much time? This is not acceptable to me. It's pretty easy. It's pretty easy question. How do you calculate A net force on the system? Now, since there are two external forces and that too they are opposite, so एक 12 Newton है on the right side and there is 6 Newton on the left side, so both of them are from the opposite side, so the net force will be 12 minus 6 upon the total mass of the system, which is 3 plus 2 plus 1, 6 kg. So 6 upon 6 will be 1 meter per second square. That is your net acceleration. This is your first thing. Second thing is, what your contact force C1. How will you calculate contact force C1? So the formula for calculating contact force C1 will be what? It will be M2 plus M3 multiplied by F1 upon M1 plus M2 plus M3. Part 1. Secondly, you will add M1 also multiplied with F2 and then M1 plus M2 plus M3. Okay, I want to calculate the contact force between okay, this is your M2, by the way. This is your M1, M2, M3. Got it? This I've taken M1, this I've taken M2, this I've taken M3 in the similar manner. And this is your F1, this is your F2. why and how I've made this formula, m2 plus m3 upon f upon. So this was before also. This you can figure out from the two mass system. We did this in the last time also. When we wanted to calculate the contact force between 3 and 2 kg, we took the mass of what, m2 and m3, this m2 and m3 plus the net force f1, which is not acting directly on them. But in this case now since there is an external force f2 also present, which is not acting directly on the 3 kg mass, so we'll take the mass of this 3 kg multiplied with f2 and then divide by the total mass. Okay, that is why I've made this formula. So if you'll solve by this formula, how much you will get? This is 2 plus 1, 3, and this f1 upon how much kitna hoga? 12 upon 6. This will be 2. So this will be 3 into 2, 6 Newton plus this will be what? 3 into 6 upon 6, 1. So 6 plus 3, this will be 9 Newton. Contact force between 3 kg and 2 kg will be 9 Newton. Okay, this is 9 Newton. And we want to calculate C2. How will we calculate C2? On the very similar formula. C2 will be M3F1. M3F1 upon total mass. Okay. Plus M2 M1 multiplied by F2 upon total mass. Do you get the logic? What I'm doing? What I'm doing? Did you get the logic? क्या कर रहा हूँ मैं? क्यों लिख रहा हूँ ये? C2 is the contact force between 2 and 1 kg. So first of all, we know it's responsible for only for pushing 1 kg block. Okay, if the force only F1 was present, what would we write? We write 1 M3 into F1 upon the total mass. Okay, this what we did previously also when we had the 2-block system. In the 3-block system, this part is extra. Why this is extra in this 3-block system now? Because there are 2 different forces and that too opposite. Okay, so this time the contact force is also due to this 6 Newton block. Okay, also due to this 6 Newton block on 3 kg and 2 kg blocks. Okay, which is your M2 and M1. So 6 Newton is also contributing some contact force on between 2 kg and 1 kg due to this F6 Newton force, and that contact force is responsible for pushing 3 kg and 2 kg towards your left hand side. That is why I've included M2 plus M1 multiplied with them by F2, because F2 is the force which is not acting directly on M2 and M1. Okay, visualization बहुत ज़्यादा है कि कौन सा M2 है कौन सा M1 है. Visualize very fast when I'm saying this, and divide by the total mass. Okay, and if you go by this formula, so your M3 is nothing but 1, and your F1 was F1 upon total mass came out to be 2. 1 into 2 plus this M2 and M1, they are nothing but 3 plus 2, 5, multiplied with your F2 upon total mass came out to be 1. This is nothing but 2 plus 5, which is equal to 7 Newton. Okay, so 197 is your answer for the 3 parts. 1 meter per second square, then 9 Newton, then 7 Newton. So I hope you understood these formulas and how I made them. That is very, very important. Out of all of this, how I'm making these formulas, what I'm doing is very, very important. Rather than calculation mistakes, focus on how sir is making the formulas and what logic he's telling while making the formulas. So follow my logic. Okay, what logic I'm giving you, and if you have any confusion with the logic, we can do this tomorrow as well. Okay, just let me know if you have some confusion. Okay, and now it's time for your zoology class. So I'll free you guys for the zoology class. All the best for that. And most of you were able to get 1 Newton, then 1.2, 9 Newton, 7 Newton, 3.2. Okay, if at all you have any doubt, okay, just let me know. Okay, goodbye everyone. Bye bye, and all the best for your zoology class. Okay, I'm ending this session. You can connect with me in personal as well, and we can discuss. Just let me know if you have doubt. When I start the tomorrow class, join 5-10 minutes before the class, and then you can ask me to explain this again. Okay, in the waiting time. So I hope you guys understood. Right? Yes or no, at least something.